The topic for this video is gas laws. The essential questions are: what is Avogadro's law and how do you use it? What is Charles' law and how do you use it? And what is Boyle's law and how do you use it? So Avogadro's law says that the volume of a gas is proportional to the number of moles. Okay, so that's assuming that the temperature and the pressure doesn't change. So this is a graph showing that they're going to be proportional. As you get more moles, you're going to have more volume, again assuming temperature and pressure are not changing. Equal moles of the gases will have the same volume as long as the temperature and pressure is the same. So here's hydrogen, oxygen, and chlorine gas. They're all taking the same amount of space up, and they all have the same number of particles there because they're equal moles. So this is the actual equation, V1 over N1, where N stands for number of moles, equals V2 over N2. So let's look at a practice problem. A certain gas has a volume of 13 liters for 1 mole at a certain temperature and pressure. Assuming the temperature and pressure are constant, what is the volume for 3.5 moles? So there's my first volume, when liters measures volume, and there's my first number of moles, which is 1. There's my second number of moles, and I need to find the second volume. So I have my formula. I'm going to plug in. I have 13 over 1 equals V2 over 3.5. At this point, I can cross multiply, and I'm going to get V2 equals 45.5 liters, and that's my answer. Okay, now let's look at Charles' law. Okay, Charles' law says that the volume of a gas varies directly with its Kelvin temperature at constant pressure. Okay, and they're also saying constant moles. So again, as temperature increases, volume is also going to increase as long as the pressure stays the same. Okay, so here's showing with a lower temperature it doesn't need as much volume. At a higher temperature it needs more volume. It's going to increase. And mathematically this equation is V1 over T1 equals V2 over T2. Okay, so you've got 2 volumes and 2 temperatures, and those temperatures do have to be in Kelvin, which we get by adding 273 to Celsius. So let's look at an example. A gas at 25 degrees occupies a volume of 6 liters. If the temperature were raised to 75 degrees, what will be the new volume? So 25 degrees, that's my first temperature. 6 liters, that's my first volume. Those two go together. Okay, second temperature is 75 degrees. And we want to find the new volume. The first thing I have to do is change these degrees Celsius to Kelvin. So I'm going to add 273, and so temperature 1 is going to be 298 Kelvin. Temperature 2 is going to be 348 Kelvin. So here's my formula, V1 over T1 equals V2 over T2, and I'm looking for V2. So I'm going to first cross multiply. Okay, so that's V1 times T2 equals V2 times T1. I want to find V2, so I'm going to divide both sides by T1 to get it all by itself, and those are going to cancel over here. So there's my formula I can use. So I'm going to plug in my numbers now. My second temperature was 348, my first volume was 6, divided by my first temperature, which was 298, and I plug that in my calculator, and I get an answer of 7 liters. Let's look at another problem. A gas has a volume of 8.5 liters at 100 degrees Celsius. To what Celsius temperature must the gas be cooled to reduce the volume to 7 liters? Okay, so I have, cancel out the units there. So I have V1 is my 8.5 liters, and the temperature that goes with that is 100 degrees, and if I add 273, I get 373. And then 7 liters is my V2, and I want to find my second temperature. So I'm going to cross multiply these first, and then I'm going to get T2 by itself. So I'm going to divide both sides by V1, and it's going to cancel on the right here. And so there is my formula. So I'm going to plug in. I've got T1 times V2 over V1, and I'm going to multiply and divide. My liters are cancel, so I'm left with Kelvin, and I end up with 307 Kelvin. And if I want to have that in Celsius, I can just subtract 273 from that, and that gives me a Celsius temperature of 34 degrees. Okay, let's look at one more. The air in a balloon having a volume of 1.8 liters has a temperature of 325 Kelvin. If the balloon is placed in a refrigerator where the temperature is 283 Kelvin, what will be its new volume? So 1.8 liters is the first volume, and the temperature that goes with that is 325. 283 is the second temperature, and we want to find volume 2. So I'm going to just, another way I can do this is just go ahead and plug in how it is. So 1.8 over 325 equals V2 over 283. I'm going to cross multiply, so I get 1.8 times 283 equals 325 times V2. I'm going to divide both sides by 325, plug all of that in my calculator. My 325s cancel over there, and I'm going to get a volume of 1.6 liters. Okay, last but not least, we have Boyle's law, and his law had to do with pressure and volume. He said pressure of a gas varies inversely with volume as long as the temperature is kept constant. So here you have on P1 you have a low pressure but a high volume. On P2 you have a high pressure but a low volume. And so this is what that graph looks like. Okay, it's the opposite of the other two. As volume increases, pressure gets lower. So the actual formula for the equation is P1 times V1 equals P2 times V2. Okay, so let's look at a couple practice problems. The helium in a 2.2 liter balloon is at a pressure of 0.95 atmospheres. If the pressure around the balloon decreases to 0.25 atmospheres, what will be the new volume of the balloon? So 2.2 liters is my first volume, and the pressure that goes with that is 0.95. 0.25 is my second pressure, and I'm looking for my second volume. So here's my equation. I'm going to get my second volume by itself, so I'm going to divide by P2 on both sides, and it's going to cancel on the right. And so that's my formula that I'm going to use. So I'm going to plug in P1 times V1 over P2, and I just put all that in the calculator. My atmospheres cancel, so I'm going to have liters as my unit, and I get 8.4. Okay, the second problem, the gas inside of a 10-liter scuba tank is under a pressure of 180 atmospheres. If the gas is transferred to a 25-liter tank, what will the new pressure be? So that's my first volume, and the pressure that goes with that is 180. 25 liters is my second volume, and I want to find the pressure. So I'm solving for P2, so I want to divide both sides by V2 to get it to cancel. And there's my formula, so I'm going to plug in. I have 180 times 10 over 25, and when I multiply all that out, I get 72 atmospheres.